Hello everyone and welcome back to another video of the Hidden Quantum Champions here at the School of Quantum. Today we are looking at Aegiq, which is a UK-based company in the optics space that is not only making quantum optics for communication, but also computers. And if you want to learn more about their products, what they are up for and what the company is all about, stay tuned for today's video and join me as we hop right into their website. And here we are on the website of Aegiq. It says Scalable Photonic Quantum Computers, a UK-based full-stack photonic quantum company powering next-generation computing for aerospace, cybersecurity, defense, energy, pharma, and AI. And in the background, we have this magic smoke going on here. So, working with government, industry, and academic partners. By engineering a complete, fully integrated quantum stack from ultra-fast deterministic single photon sources to control and software, we can deploy scalable photonic systems anywhere. Our modular all-optical architecture reduces loss, enhances stability, and shortens the path from concept to deployment. We leverage volume manufacturing and telecom-grade compatibility to speed up, scale out, while simple environmental requirements make installation and operation straightforward. This is the step change that makes quantum computing deployable at scale. And that's kind of referring to room temperature, I guess, or close to room temperature type of photonics technology. But we will learn more about that, I think, as we go on here. So our technology is built to scale. It starts with modules. Our fiber-connected photonic modules use telecom wavelength to stay fully optical from photon generation to measurement, ensuring seamless stability. So that's like the chip level. Then there's the system level, so the next integration step. We deliver solutions in minutes that other systems take months or years to achieve, all in rack-compatible setups with simple, easily deployable requirements. Manufacturing. Aegiq uses standard semiconductor processes to deliver reliable, uniform, and scalable hardware, reducing risk and accelerating market growth. And then finally, on the software side, our software unlocks customer value in optimization, simulation, and analytics, bridging today's problem to tomorrow's scalable quantum advantage. First generation quantum computer, so deployed at the UK National Quantum Computing Centre. This is the system as it is, so 3 wide racks next to each other. It says modular photonics, standard racks, and deterministic photon source. So they also, I think, make the photon source, which has been pointed out also up there in the above section. So photonic quantum computing designed to deployment. So hybrid photonic chips combine silicon and compound semiconductors manufactured at scale using foundry-based semiconductor processes, and then standard fiber connectivity for modular expansion, mild cooling, data center compatible, no millikelvin cryogenics. So still cooling is required, but it's mild, so data center compatible kind of technology on the cooling side. And then here it also says standard rack integration for simple on-premise deployment. Working with government, industry, and academic partners. Here are some listed partners that they work together with or that are partners of theirs. You have in Germany the High-Tech Gründerfonds and the Fraunhofer, but of course there's also the Royal Navy, the British Royal Navy. There's Honeywell in there as well, the UKRI, so the National Quantum Computing Centre, and other ones as well. There's BT as well here. So, and then of course there's the opportunity to contact them and to follow them. And they are based in Sheffield out of the UK. With that, let's quickly check out the technology that is behind all of this. And here we see already like the kind of rack-based fiber technology. So we see some optical fibers, light sources here. I think a picture of, I think he's even the founder. Maybe I've seen that before somewhere. So our fundamental technologies are rack-mountable photonic modules combine single photon sources with optical switching and low-loss photonic processing. So then there's the what's inside button here. So what's inside, built for scale, high-speed, fiber-connected, telecom-compatible modules, connecting photon sources with low-loss optical switching and processing using standard telecom fiber, bridging quantum photonics out to the lab and into real-world infrastructure. So how does it work? First of all, you have the telecom photon sources, a proprietary quantum dot technology. So this is the quantum dot technology is being used to make these single photon kind of deterministic single photon sources. And then on the next level here you have the routing. So you see that it looks like a chip, but actually it's not a electrical chip. Well, there might also be some electrical components on it, but it is a waveguide. So it is a photonics chip. So these might be maybe, yeah, I think it's somewhere like these are, let's say, optical connectors that you can actually use to do something with photons, like to kind of split beams, to merge beams, what you can see also up here in this little animation. So you have these connectors, and these are the optical switches, so high speed and low loss switches that are integrated on chip level. And then there's also the compute part here, so quantum processing units, silicon integrated photonic processors. So these are now, maybe these are the integrated photonics chips. Maybe not that one here, but this one is then what is this integrated photonics chip? Again, I'm not an expert when it comes to these type of things. And then there's the measurement part. So you have single photon detectors. These are probably also requiring some cooling, because usually you want to make sure that you don't have too much thermal noise, and otherwise you are detecting thermal excitations rather than your single photons. Then here, why it matters. So making quantum computing scalable and reliable, highest performance and lowest cost. And then you see this is like, what is it? This is 10,000 times fewer components and 1,000 times less, 1,000 times faster runtimes. Telecom compatibility, so telecom C-band for lowest loss, leveraging volume manufacturing, because again, these fibers, they are already manufactured at volumes, so you can basically use the same type of fiber technology. Simplified environments, no extreme cooling or vacuum systems. Here, I think I would be interested in understanding what extreme cooling means. Does it mean that you can use normal type of, let's say, water cooling based technology, or do you need liquid helium or liquid nitrogen? I think it's either liquid nitrogen or maybe even some, let's say, traditional cooling methods, but that's not really, let's say, detailed explained here. Maybe somewhere else on the website. And then scales through fiber connected modules built using commercial semiconductor processes. And that's kind of also what we see here with these kind of elements. And then next steps. So we're advancing towards deeper on-chip integration, bridging sources, switches, and bringing sources, switches, and detectors together to support error-corrected quantum systems and scalable module-to-module architectures. So higher level of integration, bringing basically everything onto the silicon. Okay. On the product side, and I think that is something that I really find interesting about them, they're not only a quantum computing company, and they're not just taking, let's say, 2 or 3 components that they're anyways making, like a detector, and selling them as single pieces to academics labs, but there's actually more to it, and that's what we can learn here on the products page. So first generation photonic quantum computer available now, okay. Can buy one, so 3 wide racks, but there's also more. So from the lab to commercial deployment, Aegiq builds networked photonic quantum systems designed to practical deployment at scale. And there we have the computer, but there's also deterministic light sources, so single photon and entangled state sources in the C-band with single mode fiber output. So this is basically selling the deterministic source itself, but also you see here the quantum link. That's where it becomes interesting, because if you read into it, it says QLess as an easily deployable system that provides highly accurate real-time detection of sophisticated temporal attacks on optical fiber. From my understanding, that means we are looking into something which is quantum key distribution or close to quantum key distribution and quantum communication here. And then, of course, there's the Lightworks SKD. Lightworks provides APIs and tools to build workflows, mix classical quantum steps, and run jobs on Aegiq systems and emulators. And then, of course, you can contact them. And just in order to make sure that what we are seeing here is actually what I'm thinking, let's quickly also check out the product details itself. So here we see it, the Quantum Link Assurance System is an easily deployable system that provides highly accurate real-time detection of sophisticated temporal attacks on optical fiber. So physical layer monitoring of high-value fiber links. It runs alongside existing data channels with standard data encryption, post-quantum, or even QKD, so quantum key distribution. It integrates seamlessly in SDN NOC workflows and is proven on metro and long-haul links, even with amplifiers. So physical layer monitor senses subtle temper eavesdropping activity using quantum-inspired signal analysis. Deployable now, so proven on field deployed fiber alongside standard network traffic and QKD network, and network friendly, uses a single DWDM channel or OSC and coexists with live traffic and amplifiers. So this can basically be integrated into your standard, let's say, telecommunication network, and it is kind of an upgrade towards this, let's say, quantum communication type of things, or quantum communication type of networks. And if you are interested in that, please also make sure to check out our playlist with the hidden quantum champions, because I've also featured other companies that are active in this space of the quantum communication. So if you're interested in that, check out the playlist. Finally, what makes QLAS unique? So what differentiates it from other solutions? Catches sophisticated attacks early, uses multiple metrics to reduce false alarms and raise precise alert in real time, locate issues fast, so support anomaly localization and OTDR based fault triage to speed recovery, fix existing networks, simple fiber input-output, no impact on data bandwidth, works on long haul with amplifiers, operationally friendly, SDN approaches with simple dashboards, and containerized API compatible with standard network operating center. So containerized API as in probably Docker container, and then of course API as in application interface, so software interface, complements post-quantum encryption and QKD, so adds real-time breach and tamper visibility defense in depth, and then long-distance operation, proven with multiple optical amplifiers over hundreds of kilometers. So that's also very interesting, and of course I would like to know a little bit more in the details how this actually works, but I guess that's nothing that you explain on the sales page, on the sales pitch. So where it fits in telecom and defense, finance, so basically everyone who is supposed to keep information secret, but also cloud interconnect, critical infrastructure, subsea, and many more. Key advantages: risk reduction, so real-time tamper detection, low friction because it deploys on today's fiber, and future-proof because it's complementary to QKD post-quantum roadmaps, supports quantum-ready networks. And then, of course, there are also the other products mentioned here again as well. Quickly checking out the blog. I'm recording this beginning of 2026, and we see here there's a blog article from end of 2025. So I think pretty much recent and up to date. It is about cracking the code to scale, and we can see if we browse through it. I think it's a pretty detailed explanation also of the technology side of things, so you can really see, let's say, also you're here with diagrams and ancilla qubits, so it's going into the technical jargon of how to implement the quantum technology. So I think this is probably targeting towards the people that are also kind of in the sphere of quantum technology, that are on the research side. But yeah, that's just my first impression. I haven't really read through it in the details for now. With that, I think we are already at the end. I'm missing a little bit the about part. There's no about part yet. But probably I'm also very early on the website. So if you found this interesting, please make sure to subscribe to this YouTube channel so you don't miss out on the next video about the next exciting company from the quantum ecosystem. With that, as always, stay hydrated and see you in the next one. Bye bye.